All right, we're on problem number 1 from your Algebra chapter 8 practice test, where we have 2 times a to the 0 power times b to the 0 power times c to the 0 power. We have to simplify this, and we notice we have exponents of 0, and anything to the 0 power will always be 1. Anything. 5 to the 0, 6 to the 0, a to the 0, x to the 0. So a to the 0 can be rewritten as 1. So can b to the 0, as can c to the 0. So we can really rewrite this as 2 times 1 times 1 times 1. And 2 times 1 times 1 times 1 is 2. Because anything to the 0 power will always be 1. Number 2, we have the square root of 2x times the square root of 2x. And based on what we did in class, we found that if we're multiplying two square roots, we can multiply what's in the square roots and then take the square root of that. So I can take 2x times 2x and then take the square root of that. And 2x times 2x is 4x squared. 2 times 2 is 4. X times x is x squared. And then I can take the square root of 4x squared. And then we can also break this down and take the square root of each of the factors in the square root. So we can take the square root of just 4 and then the square root of just x squared and evaluate those. The square root of 4 is 2. The square root of x squared is x. So this will be just 2x. Square root of 4 is 2. The square root of x squared is x. So this simplified, the square root of 2x times the square root of 2x is just 2x. Number 3, the square root of 49 times k to the 8th power. We're going to use the same process as we did on the last problem there by just breaking this down, taking the square root of 49 times the square root of k to the 8th power. I know what the square root of 49 is because 49 is a perfect square. That's 7. And I know the square root of k to the 8th because if I take the square root of anything with an exponent, I just divide the exponent in half. So what this will be is 7 times k to the 4th. The 7 comes from the square root of 49, and the k to the 4th comes from the square root of k to the 8th, because k to the 4th times k to the 4th is k to the 8th. Number 4, we have x to the 8th power divided by 3 to the negative 3rd power. We want to write this without negative exponents and simplify it. If I have a negative exponent and the base of the exponent is a fraction, what I can do is take the reciprocal of this fraction and then the exponent becomes positive. Notice this whole fraction is to the negative 3rd power. So if I take the reciprocal of that, 3 over x to the 8th, then this negative 3 becomes positive. So then I have 3 over x to the 8th to the 3rd power, which means 3 times 3 times 3 over x to the 8th times x to the 8th times x to the 8th. And if I simplify that, I get 3 to the 3rd, or you could write that as 27, divided by x to the 24th. Where does the 24th come from? It's x to the 8th to the 3rd. Since we have a power to a power, we multiply these two exponents together, leaving us with 24. Problem number 5, we have a squared times b to the 6th divided by 4 times c to the 5th, all to the 2nd power. So we're taking this whole thing here that's inside the parentheses and multiplying it by itself. So what we're going to do here is combine a couple different properties here, and we are going to get a to the 4th. And the a to the 4th comes from a squared squared. A to the power of 2 to the power of 2. Once again, we have a power to a power. And 2 times 2 is 4, which is where the a to the 4th comes from. The b to the 12th comes from b to the 6th squared. Again, power to a power. 6 times 2 is 12. The 4 squared comes from 4 being squared. 4 times 4 is 4 squared. And then the c to the 10th comes from c to the 5th squared. Power to a power. And if we were to write this out, this would say a squared times b to the 6th over 4 times c to the 5th times that same thing again, And we could write that out and see exactly that we will find this by adding those exponents together. And number 6, 50 times y to the 12th divided by 5 times y to the 5th times x to the negative 5th. First thing I see here is 50 over 5. And 50 over 5, I can simplify that because 50 over 5 is 10. And then I have y to the 12th over y to the 5th, and if I'm dividing two things that have the same base, I subtract their exponents, so 12 minus 5 will be 7. And then we add that x to the negative 5th still in the denominator. So this 10 comes from 50 divided by 5, so it's like 10 over 1. The y to the 7th comes from these 5 y's canceling out with 5 y's in the numerator, so y to the 7th in the numerator. And then x to the negative 5th still in the denominator. That didn't combine with anything, so we leave that as is. But if we want to write that with the negative exponent, we have to take this x to the negative 5th, move it to the numerator, and then that exponent will become positive, leaving us with 10 y to the 7th times x to the 5th. Now notice this 5 is a positive because when we moved this to the numerator, based on the pattern of those exponents, it becomes positive.